Hello pre-calc honor students, here we are with solving right triangles. Something you've seen in Algebra 2 Honors before, but we've already defined the trig functions in terms of x, y as a point on the terminal side of theta. Now we're going to go back to using SOHCAHTOA. That is, we can define the sine of theta as the opposite side over the hypotenuse. So when we look at a triangle, if we look at this specific acute angle in the right triangle, we call this the opposite side and this the adjacent side. Note how that would be changed if we looked at this angle. We'd call this down here the opposite side and this the adjacent side. Regardless of which angle we're looking at, which of the two acute angles, we call this the hypotenuse, the side opposite the right angle. So in SOHCAHTOA, SO stands for sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite side over the adjacent side. So from the first the letters, sine is opposite of hypotenuse. SOHCAHTOA. Now the book gets into the cosecant then is hypotenuse over opposite, and secant is then hypotenuse over adjacent, and cotangent is adjacent over opposite. Those are nice if you want to set up things in a certain order, but since the trig functions that are most readily available on the calculator are sine, cosine, tangent, we stick to these. And SOHCAHTOA. I suppose if you wanted to, you could come up with your cho, sha, cow, if you wanted to learn the other three. These should do us for now. Okay, so let's look at our first right triangle here. Find the value of b to three significant figures. So we can label these different sides in terms of our relationship. B is adjacent to 28 and A is opposite to the given angle of 28. So we relate the 28 degrees to the two sides B and A, and B is adjacent and A is opposite. Ow, no, that's not in SOHCAHTOA. Oa, SOHCAHTOA. So we use the tangent. The tangent of 28 degrees is the opposite side A over the adjacent side B, and so the tangent of 28 degrees equals 40 over B. And this is where a lot of students get messed up now, just solving this little equation. You don't divide both sides by 40. You multiply both sides by B. B times the tangent of 28 degrees equals 40. And so B equals 40 divided by the tangent of 28 degrees. And there's a calculator problem. Let's check this on our calculator. And I get 75.22905. It asks for three significant figures. So basically we can just say 75.2. That checks with the book answer. Now, I find it handy to keep everything in radian mode, and I can just use the little degree symbol, which is hiding above the vertical bar to the left of the 7. Okay, now example 2. The safety instructions for a 20-foot ladder indicate that the ladder should not be inclined at more than 70-degree angle with the ground. Suppose the ladder is leaned against the house at this angle as shown. Now, find the distance x from the base of the ladder to the foot of the ladder. Well, in this first example, we're not going to try and find y. We're just going to get x. X is adjacent. 20 is the hypotenuse. Ha. No, that's not so funny. SOHCAHTOA. Ka, the cosine. So the cosine of 70 degrees is the adjacent side x over the hypotenuse 20. So multiply both sides by 20. And we get x equals, calculator break, and I get 6.84. Now, we could use the Pythagorean theorem to find y, but I like to maybe use the Pythagorean theorem to check. And I think it's going to actually be less calculating to just go ahead and set up the trig function for finding y here now. So y is opposite, 20 is the hypotenuse, ho, no, No, not quite Christmas yet. Or it's past Christmas by the time you watch this. SOHCAHTOA, SOHCAHTOA. So, the sine of 70 degrees equals the opposite side, y, over the hypotenuse 20. So y equals 20 times the sine of 70 degrees. And I get y is approximately 18.8. So let's see if that checks out. And it does. 6.84 and 18.8 for our two answers. Now, if you want to, you can go back with the Pythagorean theorem, check that 6.84 squared plus 18.8 squared equals 20 squared. Now, example 3, the highest tower in the world is the Toronto, Canada CN Tower, but this is in 2003, 553 meters high. Wow. Observer at point A, 100 meters from the base, sights the top of the tower. Find the measure of the angle of elevation A to the nearest tenth of a degree. Angles of elevation, angles of depression are always measured off this horizontal line through the viewer. So the viewer is raising their eyes at an angle of elevation like this. Angle of elevation. So in this triangle, we can see that this is clearly the opposite side and this is the adjacent side to the angle. So oa, soka, toa, tangent. Tangent of angle A equals the opposite side 553 over the adjacent side 100. So we get the tangent of A equals 5.53, and we do the inverse tangent of 5.53 to get our angle. And it says find the nearest tenth of a degree. So let's see what the calculator tells us. And I'm getting 79.7498 degrees. To the nearest tenth then, that's 79.7 degrees. There you go. Checks with their answer in the back. Now, let's look at what is the tallest structure in the world now. At 830 meters, over half a mile high, because that's roughly 830 yards, or 1 mile is 1,609 meters. So yeah, there's definitely over half a mile high. Let's see what kind of angle we're looking at that. Is it's really straining your neck here? We're basically at 80 degrees here. Now, when we didn't quite double the height, what's that going to be? So the tangent of angle A this time is 830 over 100, or 8.3. So let's see what the calculator says on this then. A is the inverse tan of 8.3, and we get roughly 83.1 degrees. So even though you increase the height significantly, the angle that your neck is making there for the angle of elevation only went up by about 3 degrees. Okay, here's example 4. A triangle has sides of lengths 8, 8, and 4. Find the measure of the angles of the triangle to the nearest tenth of a degree. Well, we still are only dealing with right triangles, so we're going to take advantage of this isosceles triangle and drop a perpendicular down like this. Remember how in geometry you learned that if I take the perpendicular bisector of the short side, it'll divide it into two right triangles that are congruent. And so basically we have a right triangle here and a right triangle here, and it'll be the median as well. So this is 2 and 2, like this and this. And we want the angles of the triangle now to the nearest tenth. So we've got enough sides here, we don't even have to find the height here, because we can use our trigonometry to find this angle here, theta. So 8 is, let's just make the smaller triangle here with 8 and 2, and here's theta. And we've got the hypotenuse and the adjacent side, so that's cosine. So the cosine of theta equals 2 over 8, or cosine of theta equals 0.125. 0.25. and we can put this into the calculator with the inverse cosine of 0.25. And we get get 75.5 degrees. So that's the angle theta. Now, remember how from geometry, congruent sides leads to congruent angles. So our other angle over here, let's call that beta. Beta is also equal to 75.5 degrees. And now we can get the third angle by reviewing here. Let's call this alpha up here. Alpha plus 2 plus theta plus beta should equal 180 degrees. Or we could also use the right triangle thing and double it. Many approaches here. So alpha will equal 180 minus those other two angles, which are both 75.5. So alpha equals 180 minus 151 degrees, or alpha equals 29.0 degrees. So there's our three angles, 75.5, 75.5, and 29 degrees. Check. Okay, that's it. Flange out.